All right, so today we're spending all day talking about the graph of sine of x. And we're only going to graph this graph between the radians of 0 and 2 pi. Any thoughts as to why we would only graph it between 0 and 2 pi? Because what? Oh. Well, that's because this graph just repeats itself over and over again, right? So it's going to we're just going to graph one cycle to get an idea of what it looks like. All right, and there are 4 quadrants on your unit circle, right? There's quadrant 1, 2, 3, and 4. So what we're going to do is we're going to, instead of going around the quadrants in a circle, we're going to take those points and we're going to lay them out horizontally on a graph, okay? So the x-axis is going to represent our radians, or our degrees, and we're going to go from 0 to 2 pi. So what I want you to do is skip every 4 lines and make yourself a little hash mark. So like this, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, and 4. Okay, so 4 little hash marks like that. That's going to be our x-axis, and then our y-axis is we're going to go up, skip a line, go to 1, and skip a line down and go to -1. Okay? So you can kind of think of this part right here, if I draw this little line, that's being quadrant number 1. Okay, breaking this area up here, this is quadrant number 2. Breaking this up over here, this is quadrant number 3. And then finally, this stuff over here, this is broken up into quadrant number 4. Okay, so does that make sense, the 4 quadrants that we have? Okay, and remember, we're only graphing the sine function. We don't care about cosine, tangent, secant. We don't care about any of those today. We're only graphing the sine curve. All right, so let's label these points, okay? Yeah?
Wait, how is there like a...
Well, let's label our x-axis, okay? So in quadrant 1, my angle, so if this is 0 here, then when I get to the top of quadrant 1, I'm at pi over 2, right? Yeah? Okay. Then if I go all the way down, I'm at, where am I, when I keep going around the unit circle, where do I end up? Pi, good. Keep going around, where do I end up in this one over here? 3 pi over 2, right? And then finally, if I end up back to where I started, where do I end up? 2 pi. Good. That's what it means between 0 and 2 pi. That's how it's labeled between 0 and 2 pi. Okay? Now, we want the sine of x, okay? So what we're going to do is we're going to travel around the unit circle and only look at the sine values. Our sine values x or y on the unit circle? The y. So at 0, can you look at your unit circle or tell me what's the sine of 0? The sine of 0 is 0, right? So that means that here I have 0, 0 as an anchor point. Okay. How about at pi over 2? What's the sine of pi over 2? 1. Very good. Yeah, look on your unit circle, right? Think about 90 degrees straight up. 0, 1. The y value is 1. Okay, so that means at pi over 2, we have a value of 1. So the input is pi over 2. The output is 1. How about at pi? What's the sine of pi? 0. Yes, it is. Okay, the sine of pi is 0. Good. Okay, keep traveling around that circle. What's the sine of 3 pi over 2? -1. Awesome. Doing great so far. Okay, and then finally, what's the sine of 2 pi? 0 again. Okay, boom. So therefore, we have traveled all the way around the circle. So we've completed one full stage or one full cycle of the sine curve. So if we connect these with a nice smooth curve here, this is what we get. Hopefully yours looks a little bit better than mine. Now I realize this doesn't look like a whole lot, but there's so much information on this graph, it's ridiculous. Let's start with the basics here. Which 2 quadrants is sine positive? 1 and 2. How can you tell just from looking at this graph? Because it's above the x-axis. Very good. Where is sine negative? 3 and 4, because it's below the x-axis. Very good. Okay, awesome. Let's see. Can we identify what is the domain for this function here? What's the domain? What's the domain for sine of x? Well, you would say 0, 2 pi, but this graph could just keep going in either direction, left or right. It would look exactly like this. So it would be all real numbers. Okay? All real numbers. All right, let's talk about the range then. What's the highest output I could get? 1. What's the lowest I could get? -1. So my range is stuck in between -1 and 1. And I just used an interval notation to describe that, -1 to 1. All right, I've got domain, I've got range, so far so good. Let's talk about increasing and decreasing. Where is this graph increasing? Okay. Yeah, so it's increasing here, right? It's increasing in this quadrant. Where else is it increasing? Yeah, very good. Increasing. So how could I describe those points using interval notation? What would they be?
The parentheses 0,
Very good. So parentheses 0, comma, pi over 2. And what's the other one?
parentheses 3 pi over 2, comma, 2 pi.
2 pi. Very good. Awesome. Those are my two increasing intervals, right? There is another interval. There's decreasing. Where is it decreasing?
Pi over 2, pi.
Yeah. Okay, so here, from here to here, these are my increasing intervals, right? Increasing. Where is it decreasing? All the place in between. There's my decreasing interval. So it's decreasing from pi over 2 all the way up to 3 pi over 2.
You wouldn't separate into two.
No, it's because it's decreasing on that whole thing, right? Yeah. That makes sense, okay? So domain, range, increasing, decreasing, awesome. Okay, let's talk about now, the x-intercepts. Okay, can you name any x-intercepts that you see?
Pi.
Pi is one of them. Give me another one.
2 pi.
0, give me another one. 2 pi, good. Any others?
There's probably more because
There's probably more. What about 5 pi?
yeah,
What about 4 pi?
negative.
What about -3 pi? Yeah. So is there a pattern here?
Yeah, all
Yeah.
5 pies.
Whole multiples of pi.
Wait, how did you find all those?
It's a great question. How do we find those? Check it out. So that's an x-intercept. That's an x-intercept. That's an x-intercept. Whoa, sorry. That's not an x-intercept.
Wait, so it's all whole multiples of pi?
Ah, boo. Yes, all whole multiples of pi. Okay, whoa. There we go. Yeah, so that's an x-intercept, that's an x-intercept, and that's an x-intercept right there. Right? 0, 1 pi, 2 pi, 3 pi, 4 pi. It goes on forever and ever. So any whole multiple of pi is guaranteed to be an x-intercept of our graph. Yeah? Pretty good so far?
Yeah.
All right, domain, range, increasing, decreasing, x-intercept. Okay, let's talk about the period then. We have all kinds of information on this thing. Okay, the period is how long it takes to complete one full cycle. So your answer is going to be in radians here. So how many radians does it take for the sine curve to complete one full cycle? And one full cycle is this. I'm starting at 0. I go up to 1. I go back to 0. I go to -1. And then I finally go back to 0 again. That gets me back to where I started. So 0, up 1, 0, down 1, and then 0 again. What's that distance? How long did that take? 2 pi. Nice job, Matt. So the period for sine is a distance of 2 pi radians. So that means the period is defined to be the distance to complete one full cycle. And that's going to be the amplitude. Okay?
Is this the same box?
Yeah, this is all the same box, okay? The amplitude is this distance from the center line to the high point and the center line to the low point. So the amplitude for us is a value of 1. So it is 1 unit from the highest point to the center line and the highest point to the lowest point. Sorry, center line to the lowest point is a distance of 1. So the amplitude is an amplitude of 1. It's an absolute value thing.
Wait. Center line to what?
Center line to the highest point or center line to the lowest point. Either or. It doesn't matter. They need to be the same. So it's 1. It's 1 unit. So it has an amplitude of 1 as it speaks right now. But we're going to change all that in a second.
Wait, so even when it goes down, it's
Yeah, even if I shifted this whole graph down, find the center line, and then from the center line go to the lowest point and the highest point, that's defined as the amplitude. You guys with me so far still? Okay, cool. All right, let's practice some of these. But before we do, I got to tell you what the 4 main transformations are, okay? Okay, so here are the 4. Phase shift, which means we're basically just moving our graph left or right. Period means that we are how long it takes to complete one full cycle, and we'll always be graphing these things on one period. Amplitude, distance from the center to the top. And then vertical translation, moving up or moving down. Okay? So let's get an idea of what the graph actually looks like on our calculators. So you can pull your calculators up, and I'll show you actually how to graph the sine curve on the calculator. Okay? Before we begin, your graph has to be in radian mode. So the way that you figure it out is if you go to mode, third option down, you can be radian or degree. Make sure you're in radian mode. So you want to come down, highlight radian, push enter if you're not. Once we've got in radian mode, we can go to y equals, and we'll punch in the sine, which is right below the alpha button. And we want to punch in the sine of x. Because that's what we're graphing here, the sine of x. So if we all then push zoom 6, here's what we would see. We would see this little snake sort of come across the screen here, right? And, hold on, let me get back to this, okay? Go to this one. So if you look at this, right, the picture that we did and then the picture on the graph, they look different, don't they? They do. They look different, right? Which part on the calculator did we actually graph? Just this little part over here between 0 and 2 pi, right? We only needed to graph this one little part, though, because you can see that it just repeats itself over and over again in all directions. That's why the domain is all real numbers, right? Okay? So how do we make our graph look exactly like what we drew on the page? We have to change the window. So we're going to go to the window. We're going to make our window match exactly the window that we've drawn here. So we're going to ask ourselves, okay, what's the lowest x value that we have, our minimum? What's our lowest x value that you see here? 0. Very good. So put 0 in. Okay. What's our highest x value that you see? 2 pi. So punch in 2, and then the pi button is the caret button right over here. So we're going to go second pi. Everybody get that? Okay, now when you move your cursor right off that screen, your calculator is automatically going to change 2 pi to a decimal. So watch what happens when I move it off. Look, there it goes, it becomes 6.28. That's just 2 pi. It just does it automatically for you. Okay, the scale means like what increment are we using to count? Well, the quadrants are a really good increment to count. So quadrants are broken up into 90 degrees or pi over 2. So 1 pi over 2, 2 pi over 2. So the scale that we're using is pi over 2. So second pi divided by 2. And again, once we move our cursor off that screen, it automatically makes it a decimal for you. Okay, our lowest y value, what is it over here? -1. Awesome. What's our highest y value? 1. Perfect. Now when we hit graph, okay, now we're talking. The screen on our calculator matches exactly the graph that we drew. We're going to want to have that skill because that's how we're going to be able to check and see if we're doing it right. Okay? So here's the full color version of what it is, but you have this in a black and white version at your table. Okay, so this looks pretty scary, but this is a really, really useful piece of information when we're graphing these sine curves, which is what we're going to be doing today. So I'm just giving you an introduction here. So,
can you write that like first before we do this in terms of like instead of? Can you also write it like instead of?
So check this out. Notice there's a variable c, there's a variable a, there's a variable w, and then there's a variable d, as opposed to the x. Right? The x you'll always see, but these other letters will change, just like this example over here. All right. All right, the C part, the plus or minus C, notice there's 4 things here and there are 4 transformations. So each one of those variables is responsible for one of the transformations. So the C part out here, if you're adding a value to your function, means you're going to move up or down, depending if it's positive or negative. So up if positive, down if negative. The number in front of the A, like over here, the 5, right? That would tell you the amplitude. So our normal amplitude is 1. Right? And then whatever number is in front of there will tell us what the amplitude is. Now, if that number happens to be negative, then you get a reflection over the x-axis, which it says so right down there.
Wait,
Yes.
what is that?
The W part here, it tells you the period. So it's the number that's in between the actual function and the variable x. So in this case, it's a 3 pi. So how do we figure out what the period is? Well, we would take the regular period of the sine curve, which is 2 pi, and divide it by whatever number happens to be there. So the 2 pi is there because the period of sine is 2 pi. So we're going to chunk that up into whatever number we've been given here. So in this case, right over here as an example, I have 3 pi. So my period would be 2 pi divided by 3 pi, or 2/3. All right, and we'll deal with that when it comes up. And then the last one here is this x plus or minus d, this inside part, right? And that is a phase shift. So that means we're going to go left if d is positive, right if d is negative. So kind of opposite the way that you'd think it would work, just like the way our other transformations work earlier in the year. All right, so these are the 4 things we have to be able to do. Vertical translations, amplitude, reflections, period, and then a phase shift. We don't necessarily have to do all 4 at the once. That's a really tough problem. We'll probably end up doing 2 of the 4 each problem that we do. And we're going to practice that today. Okay? Okay, so on this one, negative sine x plus 2. All right, there's 2 of those 4 translations that we've done, or transformations. Can you name which 2 they are? Have we done a phase shift?
Yes.
Nope, no phase shift. Is there a period? Nope, no period. Is there an amplitude? Yep, there's a reflection, right? Okay, so this negative part out in front is going to give me a reflection. Over where? Very good. Over the x-axis. So far, so good. Yeah.
Wait, isn't the phase shift the +2?
Nope. You're thinking of this. That would be a phase shift. See the difference between the two? Okay, so the +2 on the end is a vertical translation. Okay, so these are the only 2 things that we have. The first thing and the second thing, all right? Those are the only 2 that we have to worry about. A reflection and then a vertical translation. So which one do we do first?
The reflection.
Yeah, we do amplitude first, and then we do vertical translation, right? So amplitude, then vertical translation. Okay, so here's how we're going to do this. First, we're going to set up our coordinate plane. And we have to think a little bit. We're going to translate, which means we're going to push the entire graph up 2 whole units, right? So if the highest point is already at a 1, and we're going to push it up 2 units, how tall should we make our scale? It should be at least to 3. Very good. Awesome. So we'll go 1, 2, 3. I'll go 3 like that. I'll call that -1 down there. All right? And the period is still a 2 pi. So I'll go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So I'm still going from 0 to 2 pi. And these are all my quadrant angles. Pi over 2, pi, 3 pi over 2. Okay. So the first one that we graph is y equals sine of x. That's our parent graph. Now we have 5 anchor points that we're using to graph sine of x. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, 2 pi 0.
So you just drawing your parents graph?
Yep, that's my parent graph. That's my black graph, y equals sine of x, okay? Okay, then I'm going to use a different color. I'm going to use red, and I'm going to graph, well, according to this, it says that I do the amplitude first. So that means I'm going to do a reflection, so I'm going to do negative sine of x. What's that going to do to this graph? What's it going to do to my black graph? Flip it over the x-axis, right? So if I flip this point, it stays there. If I flip pi over 2, 1, it goes down here. Pi, 3 pi over 2, and then 1. So notice you have just sort of the opposite of what you had before. You have a flipped graph there in red. And then my last graph, I'm going to graph negative sine of x, and then a +2. So that physically pushes my graph up 2 units. So each red dot goes up 2 units. 1, 2. 1, 2, 1, 2, 1, 2, and then finally 1, 2. All right? So our end graph would look like this. Notice I got my scale on the right-hand side there to tell you what each one does. All right, so we're going to graph in here negative sine of x, and then we're going to go plus 2. Okay? All right, but we got to change our window. All right, so our lowest max is still 0. Highest max still 2 pi. Scale is still pi over 2. That hasn't changed. What's our lowest y value that we have? Negative 1, right? What's our highest y value that we have? 3. Perfect. So I'm only graphing the blue line, right? So my graph on the calculator should match my blue equation that we have here. And you can see that, okay, at pi over 2, I should be at 1. Pi over 2, I'm up here at 1. At pi, I should be at 2. At pi, I'm definitely at 2. So you can check to see that your scale matches the graph that you did. Is this making sense? Feeling good? Okay, good. Awesome. So before you begin, try to identify the possible, like what of the 4 transformations, there's only one that's going on in this one. What is it?
Phase shift.
A phase shift. Good. Nice job. Which direction and by how much? To the right?
By half of pi over 4.
By pi over 4 or half a quadrant. Very good. Awesome. Okay, good. So we only have 2 things to graph on this one. So give yourself lots of room for this one, okay? So we'll count 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Good. So here's 0. Here's 2 pi. There's pi over 2. And there's 3 pi over 2. And I'll call that 1, and I'll call this negative 1. Okay? Doesn't matter what you do as long as you keep them the same. All right, so we discovered that this right here is a phase shift by pi over 4 units to the right because it's negative. Okay, so my black graph is going to be y equals sine of x. So I'll go ahead and do that. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and that. So that one is sine of x. So you can get really good at graphing sine of x because there's only 5 dots. We graph it. Every single time our period is 2 pi. Okay, I only have one thing to do. What do I have to do in this case? Shift it to the right. How many units? Pi over 4. So where is pi over 4? It's not on our scale. Where is it? Yeah, very good. It's halfway between. So this is pi over 4. So if that's pi over 4, then what does that make this one over here? No. So 1 pi over 4, 2 pi over 4, 3 pi over 4. What's this one? 4 pi over 4. What's that make this one?
5 pi.
Nah, now you got it. 5 pi over 4. Good. What's that make this one? So this one is 7 pi over 4. This one is
Wait, what are you adding to each one of those?
8 pi over 4, right? And then finally I got one more. What should be? 9 pi over 4. So this dot goes here. This dot gets moved to here. This dot gets moved to here. That dot gets moved to there. That dot gets moved to there. So you end up with this graph here. All right, so we want to graph sine of x, and then we'll go minus, and then put a second parenthesis. We'll do pi divided by 4. So it should look like that when you enter in the calculator. Okay, we got to change the window though. Okay, what's our lowest x value? X value. Can I go back? Yes. Right there.
Yeah.
How do you do then another way?
Sine x.
Because I have a pi divided by 4 here, so I want to keep that in parentheses so it doesn't go sine of x minus pi and then divide the whole thing by 4.
Wouldn't it be like plus pi of 4?
No, it says, I'm just copying down the equation, right? Minus pi over 4.
Like since it's minus, wouldn't it be that? No, remember how in the other functions when it's
Everybody good? Punching in the calculator? Yeah? Okay, good. Let's change our window. Our lowest value for x is still 0. We can keep that there. What's our highest value of x now?
9 pi over 4.
9 pi over 4. So we have to change that to, I go parentheses, 9 pi close parenthesis, and then divided by 4. Sound good? 9 pi over 4? Okay, and then when you move your cursor off, it's going to give you the decimal automatically. What's our scale that we're using now? We're no longer using pi over 2 as a scale. What's our scale? Pi over 4. Awesome. Pi divided by 4. Good. What's our lowest y value? -1. Good. What's our highest y value? 1. Awesome. So now the graph that we come up with should match identically the graph of our red one, and there it is.
But what you put in again?
Oh, it's over x-axis.
Yes. So this right here means an amplitude is going to be a value of 4 with a reflection.
Oh, that's the 2.
Yeah, that's the 2. Reflection over the x-axis. All right, then we have a period. The normal period for sine curve is a distance of 2 pi, meaning starts and ends in 2 pi. This one is different though. We actually have a number in between the actual trig function and the variable x. So, how do we figure out what the period is? We take 2 pi and we divide it by whatever number happens to be between the sine and the variable. Well, in this case, that is a 2 pi. So I'm getting a period of 1. I lost you. Okay, we used to graph this, just sine of x. That was our parent graph.
Yeah.
Well, the periods are not going to line up, right? Here, let me show you what I mean. Can we do this? Check this out. Okay. Okay, there is a regular old sine curve, right? And I'll make this in radians. Okay, so check it out. 0 to 2 pi. So far, so good? Okay, look, I start and I end at a distance of 2 pi. Okay, so what happens then if I put in a number in between sine and x, right? Okay, well, I'll start with this one. Right? What if I do this? What the hell? I did y equals, how about sine of 3x? Yeah.
The period changes.
Yeah. Holy cow. Wow. Come on now, you got it. There you go, look. Okay, so what's the difference between the red one and the blue one? Has the period increased or decreased? To what?
Pi over 4 plus a half.
To 2 pi over 3, right? That's what I did to 2 pi over 3. So what does this 3 mean, okay? This 3 means that you have to get 3 full cycles on a distance of 2 pi. That's what that 3 means, okay?
To get to what?
Okay? Look, here's 1 cycle. Here's 2 cycles. Here's 3 cycles on a distance of 2 pi. That's what the 3 means. So how do we scale it? Because we only need to graph 1 period of this. So we only need to graph from here to here. So I'm redrawing my scale just from here to here, because that is just 1 period. See the difference? Yeah? Okay, the period is hard to deal with. Really hard to deal with. So that's why, for us, making it easier by graphing the sine of 2 pi x. Our period just goes from 0 to 1 versus 0 to 2 pi. Okay, we're going to practice on Wednesday, I promise. You with it so far? Can I keep going, or do you need more explanation? All right, we'll keep going. Here we go. It has to start and end on a distance of 1 now because my period is 1. So I start at 0, and I end back at 0. Halfway between my sine curve is also at 0. A quarter of the way it's up at 1. And 3/4 of the way it's down at 1. So this represents the graph of sine of 2 pi x in red. That's the sine of 2 pi x. It's the same as before, except my period has changed. I've gone from 0 to 1. Okay, then I have to do -4 times the sine of 2 pi x. So the -4 is going to be a reflection and an amplitude. So if I reflect this point, it stays there. If I reflect this point, it would go down to -1, but then I need to increase its amplitude to 4. By the way, these are all negative. This point would stay here. This point would be reflected up to 4, and this point would stay here. So you would get this graph that looks like that.